Hi, everybody. We're going to do Q7, which is evaluating linear functions. Oh, they could be any kind of function. So we're going to evaluate functions. So here it is, Q7, evaluate a function. And this is going to be very intuitive. You see, what they tell you, and if you really follow directions, it'll make sense. Look at what it says. It says f of x equals 12 plus 9x. By the way, f of x and y are identical. There is no real difference. This is the same thing as writing y equals 12 plus 9x, because a lot of times we think of y as being a function of x. The question, though, is asking you to evaluate f of x. And I want you to notice what happened here. This is going to make a lot of sense to you. I put a 7 instead of an x, didn't I? Well, guess what I'm supposed to do? I'm supposed to put a 7 inside parentheses instead of an x. The parentheses are important because if I just write a 7 right now, it's going to look like 97. But it's not. It's 9 times 7. Notice I put an x, a 7 instead of x, and I put a 7 instead of an x. I have to now do order of operations. A common mistake is to think that everything is left to right. Order of operations says that multiplication is more important than addition. So it comes first. 9 times 7 is 63. And the 12 is still there. I'm just adding these together. That's going to give me 75, which is the function value of f of x at 7. Another way to write this is as an ordered pair. If x is 7, the y is 75, or f of x. We sometimes call it f of x. We sometimes call it y. So f of 7 is 75. Come on. Oh, there we go. Okay, this one's a much easier one. We want f of 1, and that's 2 times 1, which is, of course, 2. I'll go a little faster after a while, but for right now, I'm going to go ahead and substitute 8 minus 8 times 1, because they want me to put the 1 in for the x, and 8 minus 8 is 0, isn't it? Don't want to spend too long on this one. Okay, I hope you guys can do this. 7 times 2 is 14. This time it's an absolute value. So we have 3 minus the absolute value of the x value that they gave us. And this says take 3 minus positive 3. No matter what value you put inside of absolute values, they're positive. So we have 3 plus 3, which is 6. This number will be positive. Oh, what the heck is wrong with me? It's minus, duh, which is 0. I made a mistake. I didn't do it on purpose, but there it is. It's a very common mistake. It's looking at the absolute value and wanting to make everything positive. It is 3 minus 3, which is 0. I wanted to write that positive 3 for you, but that's where it goes, not at the subtraction level. Sorry, that was embarrassing. Okay, so 4 times negative 3 is negative 12. This is different than absolute value. 4 times negative 3 is negative 12. If it had said this, 4 times absolute value of negative 3, then it would be positive. But this is negative 12. Nothing like, I don't want to get you confused. Easy, easy, easy. Let's make it easy. Okay, for whatever reason, my students tended to panic because they see this fraction. Don't worry, x is 90. I'm going to put the 90 instead of the x. Notice this x is that 90 right there, just like they told me. And that is negative 6 plus 30. 90 divided by 3 is 30, and that's going to be 24. This one has an exponent in it. We've got parentheses 8 minus x, which is 3, squared. You have to do what's inside the parentheses first, and no, you can't distribute that square. You cannot distribute exponents unless you're dealing with multiplication. In this case, we have 8 minus 3, which is 5, and it's being squared. It's not 5 times 2, it's 5 times 5. This says multiply 5 2 times, like this, which is 25. This is 5 times the absolute value of negative 6 plus 7. Well, the absolute value of 1 is just 1. And so we get 5. I did all the steps in this particular case because I wanted to show you that it's important to go through all the steps. Notice that I didn't put equal signs. A very common mistake for students to make is that they want to write this, and this is a really, I don't know why students do this, but they love doing this. They'll write something like this: negative 6 plus 7 is equal to 1, which is equal to 1. And then they'll say, oh, but that's 5 times 1, which is equal to 5. Well, okay, this is true and this is true, but it doesn't lead from what I did. So it's really a bad habit to get into, and it can lead to some other really bad errors. So this is 5. Let's see what else we can do here. Oh, nice. We get a polynomial. That's what this thing is called. And in fact, it's called a quadratic. It has a special name. And we want f of 11. You're going to see this a lot, especially in the second half of Algebra 1 or in Algebra 2. Normally, we write these in a different order. We normally write these in the other order. It's called descending order, but it doesn't matter what order you write them in. You do have to do the exponent first. So we have 2 times 121 minus 3 plus, and I could do this multiplication right now, but I'm going to go ahead and wait. I did the exponent first. Now I'm going to do the multiplication. 2 times 121 is 242 minus 3 plus 110. And I can subtract that. That's going to be 239 plus 110, which is 349. Okay, I know I did a lot of extra work that doesn't seem necessary. And I just want to show you the mistake that I was talking about before. A lot of students will do, 11 squared is equal to 121. And then they'll say that times 2 is equal to 242. And then if I subtract 3, I get 239. And then if I add 10 times 11, or 110, I get the 349. And they say, well, I did the same thing. Really bad idea. Because what's going to happen is that so long as you can do everything in your head, you're going to be fine. But the minute that you get to a question that can't be done in your head, you're going to have problems. So keep your work nice and neat, one step at a time. It's going to make your life a lot nicer, okay? Trust me. Don't get scared. It's just 3 minus 46 divided by x, and x is 2. So 3 minus 46 divided by 2 is 23, and 3 minus 23 is negative 20. Not scary at all. It's okay. Just substitute and simplify. I promise it'll work out. 8 times 3 minus 12. Well, that's 24 minus 12, which is 12. Negative 29 over 29 is negative 1. Hopefully you can see it. I'll do this. No, it's not. That's not exactly right. F of negative 29 is negative 29 over 29, which is negative 1. This is true. Could have done it in your head, probably. Okay, this one you definitely want to write down. 7 times 2 to the x power, and there's my x. That's a 1 right there. And 2 to the first power is 2. You had to do the exponent first. A lot of people say, well, I still get the same answer. Yeah, this time 14 minus 11 is 3. Trust me, you want to do an order of operations. You want to follow directions. This says 2 times negative 9 to the second power. One of the things that is important in this problem is that the negative 9 is in parentheses. And I'm going to show you why in a minute, but I'm going to go ahead and do the problem. The exponent has to come first. And negative 9 squared is negative 9 times negative 9, which is positive 81. Then you multiply that times 2, and you're done. A really common error is for people to grab their calculator, and I promise if you grab your calculator and you start pushing buttons, there's a really good chance you'll get it wrong. And I'll show you why. You see, a lot of people will type this in their calculator. They'll say negative 9 to the second power. Maybe they'll put the little caret, and they'll hit the equal sign. And what they're going to get out is what's actually true. This right here is negative 81. And there's a difference between this, which says negative 9 times negative 9, which is positive 81, and this. This says negative 9 times 9, which is negative 81. This is not the same as that. It's a real easy mistake to make. A lot of people get really upset and don't know what happened. I actually made that error on my SAT, and I was so upset. I still remember it from 1980. That was a while back. It was this. It said which one was bigger, and I said they were equal. Of course, this one is larger because this is 4 and this is negative 4. My teacher never taught me the difference. So clearly the answer was this one is bigger, and it should have been B because column B was bigger. And what I put was C, saying they were equal. Anyway, way too much information. 1, 6, 2. All right, negative 36 divided by 6 is negative 6. I know you can do it in your head. I'll only write down the hard ones from this point on, okay? Oh, I better do this one. Square root of 100 is 10, and then I'm going to add 7. You have to do the square root first. So it's going to be 17. And yes, I can do them in my head, I promise. I'm going to write this one out, even though the answer is 288. But we have 2 times negative 2 minus 11. Oh, no, I did it wrong. It's 346 maybe squared. This is negative 13 squared, and that is 169 times 2, which is going to be 338. Ooh, made a mistake right away. I was thinking of 12 for some reason. That is the correct answer. Notice that I had that negative square business going on again. Watch out for that. And this one is going to be, oh, a nice one. Negative 12 times 2 to the third power. A lot of people are going to think that's 6. It's not. 2 times 2 times 2 is 4 times 2, which is 8. Be careful. That is negative 12 times 8, which is negative 96. What's going to happen is a lot of people are going to grab their calculator. They'll take the negative 12 times the 2 with their calculator and then take that to the third power, which is pretty big. That is definitely different than what this answer is. Looks like we're getting there. All right. Oh, negative 1 to the second power. So we got 1.26, which is the answer, by the way, times negative 1 squared. Well, that's just 1. And when you multiply by 1, nothing happens. That's why 1 is called the identity for multiplication. That's 1.26. That is all. This one, okay. We're going to take negative 2.73, divide by 2.1. Wow. Oh, dang it. Divide by 2.1, and then subtract 3.28. This is one of those cases where you probably want to have a calculator handy. And it ends up being a nice even number, so I'll just go ahead and do it in my head. 2.1 goes in here one time, and then it goes into the remainder, which is 0.63, 0.3 times. And then you're going to take 3.28 and add those together, and you get negative 4.58. If you wanted to see this on the side, it's 2.1 going into 2.73. Don't forget the negative. When you do arithmetic like this, you want to remember that the negative is there. You move the decimal over, for those of you who know how to do this. The decimal goes straight up. 21 goes into 27 one time, and that's 21, and I have 63 left over. 21 goes into 63 3 times. The trick is to remember that the negative is still there, and there's your negative 1.3. And then you're going to subtract the 3.28, and we're just adding the ones, digits, and the tenths place, and you get negative 4.58. Looks good. Oh, they're really going to make me work for it, aren't they? All right, so we have 6.32 is being multiplied by 1.13 minus 0.63, and we're squaring that. Well, this is parentheses, so that has to be done first, and it looks like that's 0.5. The next step has to be to square this, and you get 0.25 or 1/4. And if you divide this by 4, you can do it in your head. It goes in once and into 23 5 times and into 32 8 times. So it's 1.58. I did this. What I did was, instead of multiplying by 0.25, which is hard to do in your head, I divided by 4 because 0.25 is 1/4. Hopefully I didn't make any dumb errors while I did that. Should be okay. All right. 1.17 times 1 is 1.17. Remember, the identity of multiplication is 1. 1.6 to the 0 power. Okay, this one's not so bad. And I wanted to do this one for you because they've been putting this in. This x goes in the exponent. Anything at all to the 0 power is always 1. And I do mean anything. You can take, and it's 1. You can take, and it's 1. You can take any number, and it's 1. It doesn't matter what value you're talking about, it's always 1, okay? So this is 1 plus 6.27, which is 7.27. Anything to the 0 power is 1. This time it has a square root in it. We have negative 6.87 plus the square root of 4. The square root of 4 has to be done first, and that is just 2. So we have negative 4.87. Uh, 0.89, I think I'm going to write this one down, 0.89 over 8.9. A very common problem is that the decimals get mixed up and scary, and they're problematic. What I'm going to do is I'm going to simplify this fraction first by multiplying the top and bottom by 100. I'm going to multiply by 100 to move my decimals 2 places. And you'll see why I did that in a second. If I multiply this by 100, I get 89. And if I multiply this by 100, I get 890. And when you divide by 89 in the numerator and denominator, you get 1 over 10, don't you? Because when you divide by 89, you get 1, and divide by 89, and you get 10. So the answer is 1/10. It says decimal or whole number. So I have to write the decimal, which is 0.1. A lot of people are going to grab their calculator for that one, and not a good idea. You don't need to. All right, 6.25 divided by 5 plus 3.87. Hopefully you can divide that by 5. It goes in once, and it goes in twice, and it goes in 5 times. 3.87. And when I add those together, I get 5.12. Huh? Let's see. Line them up. Remember, when you add decimals, it's a good idea to put them in line. That's going to be a 2 and carry the 1. And that's a 1 and carry the 1. And that's a 5.12. And we have one last one, and we're done. I'm sorry I didn't grab the calculator to do these decimals, but I don't mind doing them. It's not that hard. Negative 7.2, and we're taking the absolute value of 0.3, which doesn't change anything. That's just 0.3. If it had been a negative, then it would change. Plus 4.05. I don't want to make a mistake, so I'm going to be a little bit careful. This doesn't change, so I'm just going to write it as parentheses now. I'm going to multiply this, and 3 times 7.2, sorry, 0.3 times 7.2. First, I'm going to take the 3 times the 72, which is 216. Now I have to move the decimal 2 places because I have one decimal place and another decimal place. And it's negative because I have a negative times a positive. And then I'm adding 4.05. It is really easy to make a mistake on this addition. This is really the same as 4.05 subtract 2.16. There's really no difference between the subtraction and adding a negative. And I'm going to go ahead and do the subtraction, and that involves some borrowing. So 4 gets, I have to borrow the 1. That gives me 10 tenths, and I have to borrow the hundredths, and it gives me 10 hundredths. So I have a 9 and an 8 and a 1. Looks like it's going to be 1.89, and that is correct, I think. Assuming I didn't make any silly errors, hopefully I'm done, and you all try it yourself and get your 100%. You might want to have a calculator handy, but be careful. Don't use the calculator in the wrong way, okay? Have a nice day. Bye.